have a few questions we can get started with, and of course, if there's any questions from the audience, we will follow up with those as well. So a question I have is that we saw a lot of different types of solutions and strategies today from both the software side and the project level. So I'd love to hear a bit more from your own individual perspectives on what are some of the major roadblocks you see in scaling building decarbonization solutions. Oh, sorry. Here you go.
I always have opinions. Can you hear me? Is that on? Okay. I mean, maybe a little bit of a contrarian here, but I think what we often see is the two biggest roadblocks is one, simply the will to act, right? We do not actually have a technological problem. We don't really have an analysis problem. What we have is a failure to act on the information we already possess, right? So what skill set does that demand? Persuasion. People, talking to people and making them want to do things. So I think we tend to root these things as a technological problem when, in fact, we have all the data the world could ever possibly need to point us to the fact that this stuff needs to get acted upon quickly and that there's, at least for the low-hanging fruit, right, there's buckets of stuff we already know how to do that no one is choosing to do. So I think one of the roadblocks is failure to act, and the other is time. That, as Brad alluded to, right, the software tells you lots of great stuff, and then you need to make it happen. And the making it happen takes like manpowers and research, and again, more persuasion to get people to do the right thing, and working with interdisciplinary teams to get the stuff off the ground. So I really think there's sort of a lack of recognition of both the blood, sweat, and tears aspect and the human skills aspect of a lot of these problems. I think they are the bigger roadblock than analysis or lack of technology.
Yeah, I think that you made the analogy of where we were with energy modeling and efficiency, and now we're kind of at the beginning of that cycle for embodied carbon. And when we look at the urgency, the time value of carbon issue, we really have to address that on all our projects now. I think it's I actually think it's more complex though in some ways than energy. So that's because it's not as intuitive, I think, to understanding the flows of carbon through all the products and in our systems. So I think that's what we're working on with our software and data model, is trying to find a way to scale that. So not every project can afford or has access to EHD and Atelier 10, and we need every project everywhere in the world having the intelligence easily to access and have the insights to be able to make decisions without David or Eleni kind of having this framework. So that's I think a challenge.
Yeah, I'll give the perspective from an owner-developer, and I think one of the big roadblocks is our aversion to risk. We are developing these we're making these huge investments in new buildings. We're talking, $500,000 for a new building, and being innovative is very risky. We want to use a new low-carbon concrete product in the foundation of a $500 million research building. What happens 20 years down the road if it turns out that innovative product was actually foolish and not genius? And now we have an issue with our foundation. That's a huge risk for a developer, and a huge risk for a developer like Stanford, who's also the owner and occupant. And so there's a financial risk there, but I think there's also a carbon risk, because then what happens to that building? It's going to get torn down prematurely because one product failed. And maybe that's an extreme example.
Determined engineering.
But we have an example of that here on campus. We did back in the 80s, did a mass timber building, and it was ahead of its time, but we learned a lot of things about, don't leave your mass timber exposed to the elements, because guess what? Wood rots. And so we had to prematurely tear down this building. And how green was that? So I think that's a really tough problem. I don't have an answer for that roadblock, unfortunately.
And In decarbonization planning at the portfolio scale, I think something that we see, I don't disagree that the data exists, and there's tons of data out there. It's just data that exists in an affordable way for the not so fancy clients. Sometimes we get people that come to us, or clients that come to us, and they have a portfolio of 30 retail strip malls, and they don't even have baseline energy use data, and they don't have a clear, affordable way to collect that data, which is something that has been a challenge. And then sometimes we get clients that have done ASHRAE Level 2 audits and detailed energy modeling on every single one of their properties. So they have a wealth of data and a budget to leverage that data, but a roadblock that we seem to see that seems to make up a large portion of the building stock that requires decarbonization measures to be applied is that there's just so little information available that is cheaply accessible, especially when budgets for decarbonization planning are often quite low. So it's a roadblock that we have faced.
I totally agree with you on the. I think that the bulk of the impact really lies with the not so fancy projects and the ones that don't have that much data. And we've definitely faced that. Like, how do you demonstrate value with that when you lack a baseline? And that's both on the data side, but even if you do have some data, I think there's also lack of standards in terms of methods of, for example, contracting that can, distribute the value in a equitable way. At least in a lot of projects that I've looked at, you try to have a baseline and say this is how for an ESCO model, this is how you're going to, do the profit sharing, and oftentimes. Especially with the less sophisticated owners, if you put any kind of calculation into the contract, it becomes such a big point of debate. If you have addition or subtraction, that's already like a lot. If you have multiplication or division, just forget it. If you want to have an energy model in the contract, then that's you're asking for trouble. So I feel like a lot of the incentive schemes around, if you have the data, then you also need the standards too, so that everyone can agree on the incentive schemes around these kinds of projects.
Great, thank you very much for sharing. Have one more question and then we can jump to the audience. So for the researchers and the students in the room, as well as the practitioners, if there's one or two things that you wish people would spend more time investigating or applying or researching, what would that be?
I mean, I think, hopefully I made this clear, but I think my top wish list item is exactly to address David's concern, right? It's bio-based carbon sequestering materials that we need to test now so that we know they will last 20 years and then we can use them all before 2050, right? Like, that's a very reasonable concern. And I think, again, I think there's a lot of interesting work happening in that area, but it's not quite fast enough, and it needs to get into installation so that we can see that it's durable and make sure it works, right? And that takes time, and we don't have time. So like, it's sort of like, as I've gone from looking at general sustainability to lots of focusing on energy to decarb to, embodied carbon, I'm like, it really rises to the top to me in importance, because the length of time it takes us to figure this stuff out is a real mismatch with the length of time we have to solve the climate crisis. And so to me, it's like that schedule imperative is like moved it to the top of my list. And again, I think there's great work happening, but I'm not sure it's happening fast enough for us to really get where we need to go in time.
So we'll just keep going this way. I'll kind of tip my hat to Martin and CIFE. I know, I don't know all the research going on these days, but I know, whatever it was, 20 years ago, 15 years ago, the research going on design process, I think is really interesting. Like, to your point about, we know how to do LCA, but we actually don't have any kind of codified or industry best practice on actually how to integrate it in to the process in a way. And I've just seen as an architect that by far the best projects with the really great photos, they happen from just amazing teams with a really clear process and working well together. So it's kind of the other extreme. I 100% agree with you. And like the other extreme, like those soft skills, like we actually have to do this as people in projects. And so I applaud that research, and I think it's really continues to be important.
I'm going to go back to the first question about barriers and add another one and suggest this is an area for research. I think one of the other big barriers is cultural. I think as a society, we've grown to expect a lot more out of our buildings. The thermal comfort range is 68 to 74. And if it's not that, then you designed the building wrong. And if you look at the main quad here at the university, it was, passive design, naturally ventilated for, 100 years. And then that wasn't enough anymore, and we put in HVAC systems. And, if you were hot, you put it on, you took off a layer. And if you were cold, you put on a sweater. Or, you'd go outside or open a window. And to Claire's point, like, we don't even have operable windows in buildings anymore. And that seemed to change with COVID, and now it's like totally forgotten. And so I think there's just a lot of cultural expectations about our buildings that make it really hard to implement some of these changes. It even goes down to, do you need a 150 square foot private office, or can you desk share and increase space utilization so we're building less? That's not a technical problem. That's an easy solution. It's a cultural barrier. And so I think we need more research into how to, convince people and shift that culture and expectations.
I think even more so than for decarbonization planning and trying to act quickly with our limited time, even more than looking at large measures, very expensive measures, HVAC retrofits, envelope retrofits, these types of things. There's so much low-hanging fruit in building operations and inefficient building operations that some of them can be very cost-effective, cheap and fast to implement. Like even just having your building recommissioned or looking at, are there any broken or sensors or actuators that aren't performing properly. They can be quick and cheap and effective. And that's something that I think every owner or user of a building should really be looking at, even before they start digging into what are kind of some of the larger, broader strokes that I can be applying to each of my buildings. Just what can I do quickly and cheaply as kind of just a starting point, just to save some carbon.
Yeah, just to add to that point, I think for me more specifically, I think understanding how to better, that first layer can be understanding how to better balance supply and demand of resources in a building by looking at that data. Like if you really understand the occupancy patterns and how people use the equipment in the building, you can supply a lot less resources to achieve the same level of performance or same level of satisfaction just because you know what's going on. And I think from some of our projects we realized there's so much kind of mystery that happens in the building that you can discover, and you can discover lots of opportunities that way. So I think that kind of vector of occupant behavior and then kind of controlling your systems against that has a lot of promise, a lot of potential.
Great, thank you very much. And now if we have any questions from our audience. Thank you.
Once again, Michał Wojtak, Mortenson. There was a study, I'm sorry, the name's not my strongest forte, but you have talked about the switch or analysis of from 5-day office to 3-day in the office, kind of an occupancy of the buildings. And I am curious if during that study there was analysis of okay, people are not in the office, right? We are using less energy, but they are at home. They are using more energy now at home. And in the office, you have a limited square footage per person, right? At home, you're probably gonna heat up the whole home while you're there. Probably additional light, additional usage of water, all that stuff, right, that is happening. Has that been factored into your study, or that was not really researched to that?
Yeah, no, that was not included in our analysis. We were just looking at kind of the office operations, but certainly, hopefully, if an office user of some sort was actually going to conduct this research on a real portfolio, we would hope that they would also include what are the new Scope 3 emissions that they'd be realizing for these avoided Scope 1 and Scope 2 emissions. It's true, yeah. No commuting. Yeah, very true. No.
Curious how you're looking at options when you started building and talk about steel and concrete. I know that mass timber is a big deal, and it's everywhere. It's actually kind of, I'll take all three of you on that one there. And so as we're looking at it, what I'm finding is that a lot of teams are going right to mass timber, and not always, may not be in the area that there may be embodied carbon as part of that. What other things are you looking at besides mass timber, and how are you doing that evaluation of mass timber versus other options?
I'll start. I mean, one thing that we're seeing when we're doing detailed measurement of some mass timber buildings is that it depends a lot on factors like not all mass timber buildings have really, really low embodied carbon, right? Because it depends how complex it requires, how much steel you actually end up with. A lot of these buildings end up with about half the structure once you get to the end of detailing is actually steel. So can you design it in a very efficient module that really relies on the wood and even the wood connections? What's going on with below ground in terms of parking and other aspects? So I think that fit of the kind of, can you design it as an architect and structural engineer in a party that actually allows you to take advantage of it, and then you're not just torturing the building to make it wood.
Yeah, I mean, I think we're in a little bit of a quandary, I think, right? Because it's very clear not every building should be mass timber. And it's very clear that concrete and steel are making progress and great things are being studied, but at the moment they can't compete with what's called a high quality, low carbon mass timber building for many building types. And so, it's a funny thing, we're like, I don't like to be an evangelist for any particular technology, and yet, if the building can be mass timber, today, at this moment in time in 2024, we don't have other alternatives that are going to do as well. Assuming it's, good mass timber. Not all mass timber is created equal. It has to be like sustainably harvested so you get all the value of the carbon sequestration, right? But it's a really, we feel like we're in a tight situation where it's like, I certainly don't want to advocate for all buildings being the same material. And globally speaking, right, that wouldn't really be possible. In North America, we probably could build all of mass timber if we wanted to. In other parts of the world, that would not be a sustainable solution, right? So there's this true need for conventional materials to get where they need to go so that they come back on the table as a great low carbon option. And there's a lot of roadblocks to that happening. So in the concrete world, there's a lot of good stuff happening that gets you like 30% savings in your concrete GHGs. And then there's innovation happening that would push it further, but it's not ready for market yet. In steel, it's a little bit tougher. There's like a real pipeline problem I think we'll have with like getting the entire market to be super low carbon steel. We hope it could happen, but there's some big challenges there. So it's funny where it feels like this is an answer that's going to change every single year as the market matures. But right now, we find ourselves being advocates for it in a way that I don't particularly like. And I hope that we'll like see the market rise to meet that, so we start to have more like arrows in our quiver again. And the term in building is like, I'm working on the Stanford Door School of Sustainability, where this is one of the hot topics, right? Where you're like, oh, you had a building that failed in the history of the campus, and are we pushing for mass timber, and is that really our only option? And we're sort of grappling with these in a very existential way, and it's a real challenge.
I thought your presentation on what you guys are, your trial project or pilot project was really interesting. So I'm in concrete, right? So we do precast concrete. And we've done a number of things over the years, and we've actually found that 20% target that you're hitting is right about where we're landing as something we can do for free. Doesn't cost a thing, right? We've done, sustainable energy, solar. We're doing SEM replacement in our concrete, and all those things added together are about 20% improvement overall. And it really didn't cost anything. Might even save money. Probably didn't save money, but it's about the same.
Sorry, so you're Clark Pacific. So as a precast supplier, you're able to get 20% reduction for your products.
So we're basically doing 20% whether you ask for it or not. That's what you get across the market. And then if you want more, we'll work with you to give you more, type of thing. But I guess my question comes to the 20%. It sounds like you're targeting that. Are you planning on ratcheting that up over time?
Yes.
Okay. As you see successes.
Yeah, and as other products come to market that are lower carbon, I think, the 20% goal, that was, I think, a little conservative. We didn't want to overcommit and find out that was going to cost money to reach that goal, and have, we're talking about a $2 billion capital plan. Yeah. And if we set a goal that's going to add 3% to that, that's a big number. And so, we want to start with the process to get those ideas going and get our teams, used to doing this on projects, and over time increase, raise the bar, basically.
Oh, very cool.
Yeah.
Hey, so this question for you all. I can remember being a young PM and lead AP was the big thing. You couldn't even get a job if you didn't have lead AP. But I've kind of noticed, that requirement kind of take a nosedive over the last 10 years. And I know we're trying to ratchet up towards sustainability, but I guess a couple parts of this question is who's driving the sustainability effort now? Because if I'm not, as a construction manager, I'm not required to get lead AP anymore to get a job, I don't have any way to drive sustainability. So who's driving that? How can I affect any of that change as a construction manager if I'm not able to drive that push towards sustainability? And then kind of the second part of it, I noticed, maybe I'm largely ignorant on sustainability, but I saw 3 different processes for how we get to sustainability. Is there any effort to standardize that process to sustainability so we can all get on board, and we all know exactly what to do to get there?
I think just to maybe combine both questions just with one answer for me is I think lead it's easy to kind of have it be a punching bag because it's checklist or whatever. But in fact, some of the best people in the industry volunteer on these committees, and lead version 5 is coming out now. It keeps getting, ratcheting both harder but also more sophisticated. There's going to be a credit to do early stage whole life carbon assessment as a prerequisite. So I think that lead is still as valid as ever, and I agree with you, especially on projects, unlike most projects. It's really valuable just to hold people's feet to the fire and just have a clear, this is what we're doing. You have to submit this. So I still think it's really the best standard out there, and I support it.
Go ahead.
I was just going to say, for building portfolio decarbonization, you might wonder why people are even approaching us, and they lack data. They don't have a lot of information. So why are they trying to do this decarbonization planning? And what we're hearing is because of the building performance standards that are coming into play. Local Law 97 in New York, Boston's got one, DC's got one, the Vancouver STEP program. It's really the kind of the stick that's coming. seems to be encouraging the conversation.
Yeah, I mean, I think I would say in general, yes, it's like a pretty heterogeneous group, right? And in some ways, I think it always will be, right? We're trying to keep pushing ahead, right? And so there's a little bit of a resistance, I think, to like settling on one way or one set of issues because we keep realizing we're leaving things out of the conversation, right? I mean, for the longest time, you're like energy cost. Oops, we forgot about carbon. Oh, we forgot about red list. Oh, we forgot about these things. So there's this constant effort, sometimes counterproductive, but this constant effort to say, hey, we need to like reset the bar. And so, I mean, that's what we're trying to do as well, right? Reset the bar. But I totally agree with Brad at the same time that, I think there are a lot of efforts underway to harmonize and to basically say, we're so heterogeneous at the moment that it's getting in the way of manufacturing meeting our request, right? So like Mindful Materials, I think, has taken the lead on saying, hey, can we like get everyone to ask for the same stuff in the same format so we can make it easier for folks to respond to us? There's a lot of those efforts underway in the embodied carbon world as well. But I do totally agree that I have always had like a love-hate relationship with LEED. I do a lot of LEED, but I think it's great for setting, I don't want to say the floor is in like a code compliance floor, but like a floor where like if folks are doing it, then they are conversant in the range of sustainability issues. They understand a sort of mass market approach to them. And there's a quality assurance perspective of like someone's going to check your homework, so you better actually do it. It's super useful in that. So I don't want to give it up either. I think even though it's not necessarily calculating things the way I love the most or aiming as high as I want, it's performing this really useful function to make sure we actually do something.
Yeah, because as a non-design professional, I have no way to drive, sustainability other than to count on you guys to do it and then execute, lead, so.
I'll throw in one more. You're asking about, as a CM, how do you drive that process? And a couple thoughts. One, one of the reasons I love working here at Stanford is we're developers and owners and tenants. In the market, you have a lot of developers who are developing for sale product, and I hate to say it, but environmental goals are often at odds with profit. And so it makes it really challenging. One of the benefits of LEED is that you can actually say, hey, this is a LEED certified building. It actually adds value to the product. And so I think that's a huge benefit of LEED. Also, one of the reasons why we don't do it here at Stanford, because there's really no value add for us. We're not looking to sell our buildings. And if we're going to spend $50,000 getting a piece of paper, we'd rather spend $50,000 making our buildings greener. But we're not the whole industry in North America. So I think LEED's great in terms of what it's been able to do for the market and push the envelope to make the market greener.
Maybe one last quick thing that I'm not sure folks are all aware of, but I think there's starting to be a regulatory stick that will also add to this, right? And it has to do with California's requirements around reporting greenhouse gas emissions, and then the SEC's proposed requirements that they suspended, right? But all of this is sort of leading to have a corporate incentive for at least reporting, if not reducing greenhouse gas emissions, right? And that flows through down to the built environment in very weird ways. Like at the moment, it's floating through these disclosures, which floats through GRES, which leads you to LEED, and you're sort of like, oh no, more labels. It gets a little bit confusing, but there is starting to be, I think, an external pressure at a corporate level for this stuff to get reported, and then there's a way that the built environment fits into that. And it's a little bit indirect, but I think we will start to see that happen more. And my hope is it will combat at least a little bit what David's talking about. But it also responds to this question of like dealing with it at a portfolio scale and how can we create a framework that might be consistent, right? So we're not quite there yet in the built environment and having us be part of that conversation. It's mostly scope 1 and scope 2 for now, but it's coming.
So actually kind of picking up on your comment, I've seen CMs having a huge impact on whether the building ended up not just planned for sustainability, but actually performing. And so I'm curious whether, like in the headquarters, AIA headquarters specifically, but also more generally, what you see, because I've seen too many buildings, and I wonder whether I was just unlucky in having seen these cases where there was a great plan at the beginning, and then the sustainability performance was basically died by a number, thousands of little cuts, well-meaning change orders that happened over the life of a project. And I think my reflection was that if you propose a change order that would imperil the structural integrity of the building, or really change the schedule or cost dramatically, the project, the CM organization would have an allergic reaction to that request. But we don't have that allergic reaction yet to energy, carbon, those kinds of performance. Yeah, I'm curious whether you see this challenge still, and what guardrails are you using to ensure that doesn't happen?
Well, let me tell you a heartwarming story. And it goes to the topic of culture, I think. So our client has been the Exploratorium Science Museum in San Francisco. We helped them move out of the Palace of Fine Arts, which is very emotionally fraught for everyone who grew up in the Bay Area. But early on, we set with them the goal of being the largest net zero energy museum in the world. And they opened in 2014. And for those who know the museum, they make lightning and crazy things. It's not just normal plug loads like monitors. It's a whole very unique animal. But what we, EHD with Peter Rumsey again, really explained and built the understanding through the process. It's a living goal, and we're going to set up the building that it's possible to achieve it, but it's on you guys, the operation, to actually achieve it. We can't achieve it. And they didn't achieve it at first. There were lots of things not quite right. At some point, they realized that it's over the pier. So seagulls were pooping all over the PV panels. So we had to come up with a way to put wires around her so they wouldn't land. On and on. 10 years in, this year, they've achieved their net zero energy goal, and they fully own it. So it's that. We had the similar thing at the Packard Foundation, where, they met at the year one, but they really took ownership over it in the operations team. So I think that's kind of a long story, but I think the point being, there is the change order problem, but buildings are living, breathing things. That's really where the energy is used. So I think as designers and as contractors and CMs, that cultural, like the design process and construction process, is also a time to really build alignment around the goals and explain to people like, okay, this is the baby, we're delivering it, and now you have to actually raise it.
I would just add maybe one note. I think you have such an interesting analogy there around structural engineering, right? And just from a process standpoint, one of the things, I think a lot of folks have intuition that like, hey, if I change the structural material, that will change the structure, and maybe I need the structural engineer to check that. And they know they need the structural on board to do that during construction, right? When it comes to sustainability, people don't have that intuition. So they don't know what they might change that actually will cause a big problem. And this is just like a totally self-interested statement, but they don't like to pay their sustainability consultant to stay on board, right? So we're not seeing all of the changes that happen because people don't want to pay us to be involved. And then no one else has the intuition about what they might change. And so we do see a lot of very unintentional changes. So like even if we're like vetting submittals for all the stuff we sort of agreed beforehand we would do, there's often a design change that happens or a fit out or something. Like my least favorite is like people decide to paint all the walls red and now our daylighting sucks. And you're like, oh my God, we didn't know they were gonna do that. That wasn't in the design drawings. But the branding consultant came in and said, the university color is red, let's make everything red. And this happens again and again and again and again, super late stage stuff. And again, no one understands that will have a performance impact. So I think it's, partly the team kind of looking out for each other and saying like, hey, do we understand enough about this to maybe flag something as an issue? And then maybe also realizing that like, if we care about this, we need to make sure we've got folks really involved through the whole process to keep on top of it like we would for structure, like we would for other things that we value.
I got it. So I've been thinking about this initial premise of the building being the center of the decarbonization ecosystem, and I compare that to transportation, and it's not clear in my mind why transportation is not the center, because having come down here from Marin today and sitting in traffic on 280 during an accident for an hour with a million other cars, it seems to me that if we can't figure out how to get people efficiently where they need to go, then what's the point of having that central building that's half occupied versus satellite buildings or smaller centers or basically all these other things? So my question is, I guess, have they done a study to validate that premise that the building is in fact the center of the decarbonization ecosystem?
Totally not. That is my thesis that you can totally argue with, and it's a great debate. I mean, so the reason, I mean, it's an excellent point, right? And transportation is obviously the other big red herring. And so the reason I feel like we as, like, let's call it planning and design professionals kind of need to force ourselves to take center stage is, first of all, we're the ones drawing people to these places that they can't get to, right? Like, architects are not usually responsible for site selection, but still, like, where we're involved in that process, right? We're kind of involved, let's say, as a group, at figuring out where the stuff's going to go, and the fact that we're okay putting it where no one can get to, and therefore requiring single occupancy vehicles, right? It's kind of on us as folks involved in the built environment that we've created that situation over many, many, many decades. The only other piece there is, I think, around some of these other bits, like, I think the transportation world is less connected to the material ecosystem we need to change and to the literal plant-based ecosystem that we need to connect into, right? So if you're looking at, like, I'm going to call them, which pieces of natural or human infrastructure do we need to transform, right? It's our energy systems, our water systems, transportation, material ecosystems, right? And if you look at transit, that isn't connected as strongly to materials or actual ecosystems, right? Or to our cultural institutions in the same way and those sorts of things. So in my mind, if you're saying what's everything that needs to transform and is there something that touches it all, my thesis is that buildings touch more of it than just transportation. You could totally argue with that. Transportation is unbelievably important. The challenges there are incredibly difficult to unpick. Now that we've developed in the pattern we have, it's very difficult to solve. So I'd say that in no way to diminish the importance of looking at transportation as, like, one of the major challenges, right? It's the other big piece of the global greenhouse gas emissions pie that we haven't really sorted, especially here.
I had a question for Claire or Brad, or both of you, regarding the principles of existing buildings as a material bank or maximizing material reuse as much as possible. I'm particularly curious about drywall assemblies. Because drywall is relatively inexpensive, they usually end up being diverted to landfills during retrofits. But beyond their carbon consequence, they also contribute to sulfur dioxide in landfills. So I was curious if either of you have worked with drywall or reusing drywall as much as possible without resorting to recycling or landfill.
I have not, although I agree that it's very important.
Yeah, I think it's kind of it's designed it's not designed for deconstruction, drywall. Like, that's what's made it so kind of relatively cheap and easy. You just, you can sheet, put it up, tear it out. But I think that it definitely goes back to the responsibility of designers and owners to think about the churn and, are you designing things that are inflexible and designed too tightly for a specific use, or are you designing things that actually can be flexibly used in different ways, designing spaces? And it's a cultural, at Stanford there are labs that need very, very specific things. That's an outlier case. But in general, most buildings, if there was a cultural shift, let's say, that accepted and made more use of spaces as they exist, I think that would do a lot to reduce that landfill.
I think the whole drywall assembly is, I don't know, it's old technology. It needs to be re-envisioned and reinvented and redesigned. It's extract metal and chipboard, coat it in paper, throw it in the wall. When you're done with it, throw it in the landfill. There is no way to reuse it. Maybe you could recycle the metal studs, but I think we need to look at alternate designs. I mean, there's demountable partitions that, I don't know, in theory could be dismantled and reassembled. So if you had, an open office space, you could move the walls around without really any of that material, again, in theory, going to a landfill. So I think there's other systems out there that might lend themselves to reuse and design for deconstruction, but I don't know, the industry is just not quite there yet. And I think it's going to mean moving away from some of these systems that we've used for a long time. Maybe in the grand scheme of things, it's not that long. I mean, how long has drywall been around? I don't know. Probably not that long. So it's kind of funny to think that, like, oh, we can't build a building without drywall? We can't do that. It's like, well, we did it for a really long time.
Hi, I'm Chris. I'm a local architect here in Palo Alto, also a co-founder of the TAD Journal, which is a peer-reviewed journal committed to building technology. Thank you, Claire, for your contribution years ago. My question is in the theme of innovation and sustainability. I want to invite the panel to please share insights and give recommendations for how we might navigate the trade-offs of building integrated battery storage. I certainly recognize that there are desirable upticks in terms of energy reliability on a per building basis. And I also recognize that there are impacts to carbon accounting. But I'm curious how you're thinking about it. If anything, let me just share, I'm a little surprised that it hasn't come up in the conversation so far. Thanks.
You want to go first? Do you have anything? The other case study I was thinking about presenting instead of this one is relevant. It's Sonoma Clean Power headquarters up in Santa Rosa, where we designed a grid optimal building. So there's batteries, there's some PVs, and the battery is being run with a real-time signal from WattTime, which is a company based in Emeryville, a spin out from Rocky Mountain Institute, that basically delivers a signal on the real carbon intensity of the grid, a predictive signal. So we've kind of tricked the battery to run not to optimize for cost, but for carbon. So I think that is either rates, the structures are going to change to really match carbon, which is probably more likely, but they're not quite there yet. They're getting closer in places like California, but not everywhere. But I think that kind of carbon arbitrage aspect of batteries is not yet really seen a lot of action, but that's a real great potential to link kind of batteries to actual carbon impacts.
From the projects that I've worked on, mostly, since we work mostly in the retrofit space, and a lot of the issue is that there's not enough outdoor space to place the batteries, and if you place them indoors, then there's a safety liability. So that's the issue that we've run into. So, but I think the concept of storage in general is really, really interesting if you have enough indoor space. So we do, a lot of the projects that we work on have hot water energy storage, especially in the north. The density, the capacity isn't that high, but then the cost effectiveness is really good. We've looked at phase change materials, but those are not as robust, especially if it's organic. And some inorganic variants are coming out, but then they're a little too expensive, so the payback doesn't quite make sense yet. But I think it's definitely a trend, especially if you can get around the safety barrier. That's with the electric batteries have been the main problem for us there.
Great. Sorry, go ahead.
Oh, I was just going to add very quickly. In decarbonization planning, battery storage has certainly been something that people have asked us about, and optimizing PV panel size, battery storage size, etc. When we do our parametric energy modeling, we have access to all of the 15-minute increment energy use. Of course, they're not actuals. These are kind of special box models for each of your properties. They're not perfect, but they can show you relative expectations. But one thing that has stopped us from shifting our entire backend to hourly analysis is the computational time required to then do the carbon calculations, especially for a portfolio at scale. It's not that bad, but if we're talking about like 50, 200 buildings, then it starts to get expensive for us to provide a cloud-based service to you for that optimization. So that is a barrier that we've faced.
I'm way out of my depth on this topic, but if you're curious about what Stanford's doing in this area, I'd be happy to put you in touch with some colleagues offline who are taking a deep dive.
Great, I think that's our time. So I'd like to thank again our panelists and guest speakers. And yeah, thank you so much. And I'll hand it back to Professor Fisher.